Good evening, everyone. I hope everyone will be fine in this pandemic situation. All of you stay in home. So, welcome to this session and webinar on model design of solar energy using MATLAB is organizing by Jeppiaar Engineering College, Department of Electrical and Electronics Engineering, and our sincere thanks to Jappeiar Engineering College Management, late Colonel Dr. Jeppiar, founder of Jappeiar Engineering College. Jappeiar Engineering College was affiliated to Anna University and established in 2001. From the last 2 decades, Jappeiar Engineering College producing good quality students, industrial oriented students it's producing. So located in Chennai, and our sincere thanks to Principal of Jappeiar Engineering College, Dr. V. Natarajan sir, and Chief Patron, Dr. N. Regina Jappeiar Madam. And so without any delay for accepting this program with association with Pantech e-learning, so convener Dr. V. Sridevi, Professor and Head of the Department of Electrical and Electronics Engineering. We are glad to thank you, Madam. And co-conveners, Dr. M. Shasikumar Sir, Associate Professor, Department of EEE. So, and all the participants, a warm welcome to this session. In this session, we will discuss about model design of a solar energy using MATLAB Simulink model. So, myself, Srinivasulu, Ala, and I completed my BTech and MTech in power systems. So our Pantech profile. So our profile Pantech solutions was originated in 2004. We have 7 branches and more than 100 employees are working in different branches. So we conducted already more than 200 workshops we conducted with an hands-on experience, and we reached our knowledge. We given our knowledge, our best knowledge. We given more than 8,50,000 students we reached, and our portfolio research and development for industry projects and faculty development programs, hands-on training workshops on different mode, and internships and in-plant trainings, and short-term courses and value-add courses, academic project training, Pantech project, and customized design service and state-of-the research and development by Pantech solutions. And here, which domains we are offering the knowledge, which domains we are working on: Internet of Things, artificial intelligence, embedded systems, robotics, VLSI, FPGA, TMS processors, and image processing and OpenCV, network simulation and wireless communication, and power electronics and e-vehicle, electric vehicle designing, and electronics and electrical people. We are offering these many domains. We are offering the courses and value internships and programs. We are conducting so many programs. And computer science and IT domain people, we are offering big data, data analytics, Internet of Things, Python, Android application development, and data and image and text mining, cloud computing, mobile computing. So in all these domains, we are offering, we are giving knowledge to the people, to the engineering students and the faculties, and we are working on in these areas some projects. Here, the content we will discuss in this session. Which content we will discuss here? Need of solar power. So webinar on, our target is, what is our topic? Webinar on design of a solar energy. So if you observe, these are the contents we will discuss. Needs of solar power. Why we need solar power? We need to question ourselves. So what is the motivation we need? So types of solar PV system, off-grid system and on-grid system. How the solar system fit together? how the solar system fit together, basic types of solar charge controller. When you people are install a solar PV system, then how to charge the power, how to track the power from the sunlight without any interruption. So the basic types of solar charge controllers, here we will discuss what are the benefits of by utilizing the charge controllers in your home application or solar standalone PV system. What are the benefits when we are using solar charge controllers, and the applications in which area this off-grid system or on-grid system, what are the application also we will discuss here. So before starting about this content, need of solar power, why we need solar power, we need to question ourselves. So everyone well know about the solar energy, the cleanest and most inexhaustible form of all known energy sources. Whatever the energy sources we know, so as per the resource persons IEEE standards, whatever the energy sources we are using now, we are most of the power all over the globe. If you observe, we are generating the power, most of the power by using the conventional energy sources only. So then carbon emission will happen. So atmospheric pollution become more. So we need to reduce the atmospheric pollution. So we are shifted to solar power energy. Solar power energy. So it is a cleanest power and most inexhaustible form. It is a free of source also. The sun provides massive amounts of renewable energy that can be harnessed to provide us with heat and electricity. With the heat and electricity, the two key requirements for running the modern world. We are in the modern world. So in this modern world, the amount of solar energy that falls on the earth in just 1 hour is enough to power the world for a whole year. So 1 hour from the sunlight, whatever the power we are getting, we can utilize that power. That 1 hour power we can effectively usage, means it is sufficient to per 1 year whole the world it is sufficient. So then how we are utilizing that power, whether we are preferring renewable energy sources, whether we are preferring conventional energy sources, we need to think that one. So here, what is the motivation we need? What is the motivation? In which case we need to motivation? Solar power is good for the environment, right? Solar power is good for the environment. Solar electricity makes your home go off the grid. Solar electricity makes your home go off the grid. So if you prefer at your home application, you people know how much power you are consuming per month, you know, right? So as per that, if you are fixed a solar PV installation, whether off grid or on grid, if your installation done means, then you can utilize that power, means effectively you can give the free pollution, right? So less pollution and reducing the electricity bills also. When you are using solar PV system, once installation done, then no need of pay any electricity bill to the customer, to the energy people, those who are now we are taking from the grid connected people, right? Some from the supply we are taking grid connected sign. So from the last 3 months, now everyone they are thinking about we are getting more power bill, right? So they are increase the tariffs and they are given high amount of power bill. Then how to reduce your electricity bill? By implementing the solar electricity, solar PV system. If you people are installed on your top of your home, then you can reduce the power bill, you can reduce the electricity bill. And here solar power causes less electricity loss. So if you observe the Indian power system network, so as per the research analysis, so most of the power losses occurred by transmitting the through transmission line, by transmitting the power from the generation point to, we are transmitting the power to the grid, from the grid we are distributing. So how much power Chennai people will need, how much power Coimbatore people will need, how much power the Chengalpattu will need. So we are distributing, we are generating the power from the nuclear power plant, thermal power plant, hydro power plant and renewable energy sources. We are connected to the grid, from the grid we are distributing the power. So then grid people will decide how much power Chennai need. how much power Chengalpattu need, how much power Kanchipuram need. So they are distributing. So in industrial area, most of the loads they are working on 3 phase. So they will give most of the power to that people. And how you need to, so here how you people need to reduce the loss, electricity losses. When you are transmitting the power, 20 to 30% per annum, per every year, we are getting the most of the losses, 20 to 30% losses are occurring in by transmitting the power in transmission lines only. Solar power here, it causes less electricity loss. Solar power improves the grid security also. Solar power improves the grid security. Solar power creates job and economic growth also. Solar power is a free source of energy. So from the nature itself, we don't pay any single rupee, we don't pay on solar power. Now, whatever the energy sources we are using on our bikes, on our vehicles, on our power generation, we are utilizing the power now. So we are importing the coal from other countries or other states. So automatically the people will increase the price, right? So they are increasing the prices automatically. So when you people are purchasing, when we are whatever the conventional energy sources, what are the conventional energy sources normally? Petrol, diesel, fuel, natural gas, uranium, right? So as per the IEEE standards, from within the 200 years, these will, from the earth itself, it will be disappear. So then how the world will be sustained? How the world will be sustained after 200 years? Because by utilizing these energy sources, we are more global warming. We are talking about global warming also, right? So we need to decrease the atmospheric pollution. So we are avoiding that energy sources. We are shifted to the solar energy and wind energy also. In that one, in renewable energy sources case, solar power is a major source. Solar power is a major source here, and here we have two types of solar PV systems. We have majorly two types of PV system. If you observe here, off grid, one is off grid and another one is on grid system. So what is the benefit when you people are using off grid system? So day by day, the price of solar panels falls gradually. But still, installation of a complete off-grid solar system is costly due to lack of knowledge and information. We don't know exact knowledge about the off-grid system. That's the reason we are paying more amount of for installation purpose. We are paying lakhs of amount we are paying to the solar companies. So they are benefiting, but we are not getting that information. If we people are getting some information, we can easily ready economically. We people will benefit. So in off-grid or standalone solar PV. Suppose Jeppiaar Engineering College, we install one standalone PV system. Standalone PV system is 110 megawatt, or we need to estimate how much power it is consuming per month. So according to that, we fix solar PV system, standalone PV system. That means autonomous, like autonomous engineering college or autonomous university. So we can generate the power, we can distribute to all the loads, all the computer or labs. We will generate the power different depending upon load situation. So an off-grid or standalone solar PV system is when solar PV system is not connected to the utility grid. So off-grid system case, we are not connected to the grid. We are independent people. Suppose remote sensing area or Andaman Nicobar Devulu, right, or Lakshadweep. So then how they are not interacting to the grid, right? So the people need power. They need to run their loads at their home applications. So then if the people are select off-grid system, it is very useful also. So when solar PV system not connected to the utility grid, we are producing own electricity via solar. It is called as an off-grid PV system. Suppose here if you are observing the figure, solar panels and the charge controller, we are connected to the battery. Off-grid means we are generating the power from the solar PV panels. Top of the solar panel, it is tracking the power. So here normally people tell me which power we are getting, solar PV system, which power we are generating. The photovoltaic energy will be converted into the electrical energy, right? So the photovoltaic energy is converted into the electrical energy as it's based on the PN junction diode principle. PN junction diode principle, it is converted the photovoltaic energy into electrical energy. So this charge controller will help to track the maximum power. Because if you are observing the temperature from morning to evening, it will be vary. Simultaneously the temperatures are vary. So then how to tackle, so how to run our loads at our home system. If you are fixing on top of your home, then how you people run all the loads at a time? So by using the charge controller. So if you people are generating more power, you are generating from the daytime, right? When you are generating more amount of power, you can store that energy in the battery banks. Other battery banks or fuel cells you can fix, means then in that one you can store the energy. Suppose in our home applications most of the loads are AC loads, right? Except our electronic devices or mobile phones, remaining all the devices are AC loads. Whatever it is, fan or refrigerator or AC, all the loads they are working on with only AC supply only. Then how you people convert DC into AC means compulsory we need one power electronic converter. That is, here we are fixed, one inverter we are fixed. So then you people from the battery itself we can take DC, that DC we can convert into AC, means then all the loads at our home applications we can run with AC supply only. So this is off-grid system. If you observe here, how the solar works, top of your home you are fixing solar panels, convert sun energy into the electricity, it is converted. So this solar panel you are tracking the sunlight. So the temperature, if you are fixed how many panels, 6 panels you are fixed. So whether it is a 1 kilowatt or 2 kilowatt, you are fixing 6 panels, right? So if you are observing clearly the temperatures, whatever the temperatures, the sun rays are falling on, here the sun rays or temperature is very low, right, in this corner side, and here the temperature is in middle point, the temperature is very high, in the corner point the temperature is very less. So then the voltage mismatching problem will occur, So that's the reason we are preferring with charge controller, MPPT charge controller. We are preferring with charge controller. Here solar panels converting that one. Then here we are fixed on charge controller. It will help to track the maximum power from the PV panel. At one point only we are getting, one fixed point only we are getting maximum power, right? So from that point this solar charge controller will help to track the maximum power, and it will give to the battery. From that battery we can utilize all the loads. A control device changes the electricity, enabling it to power electrical items. So this is the how solar works at your home applications. So on-grid system, if you remember here, off-grid system or on-grid system. On-grid means a solar system is tied to local utility company systems, either sub distribution systems, right? So if we connect it to distribution, whatever the power we are generating, so the excess power we have, the excess power, if you are not, if you are storing the energy in the form of battery, means the battery cost is very high. If you are observing at your home, if you are observing your ACs also, the cost of AC is high. So why it is very high means because of the battery. We are storing the energy, the batteries, means the battery cost is more. So we need to reduce the cost, means whatever the power we are generating, that power we can utilize at our loads. Remaining excess power, if you are generating that power, if you connect it to the grid connection, utility grid, from the substation itself we are taking the power, right? If you connect it to the grid, means that grid people will pay the bill monthly. So then you can profit, right? At the time you are getting profit only, right? So on-grid system are linked with the power utilities, which enable the home to the user power generated by the solar system as well as the power from the local utility. You can give that power to the grid people, means they will distribute that power to other customers also. Here these systems can also be feed power back into the grid during times of low usage and high production. The solar energy, grid tie inverter, and here we are getting DC current only, or DC voltage, DC power only we are getting. So that one, if we give to the DC to AC converter topology, that one converted into the AC, then whatever the devices at your home, whatever meter, net metering, and here you are connecting through the transmission network, right? So these loads, AC loads you are connected, whatever fans, regulate, all the loads at our home application, those are all AC loads also. So being grid tied is beneficial because we don't have to buy an expensive battery backup system to store any excess energy. Any excess energy we don't want to store, we are directly connected to the grid, means that grid people will pay the bill how much, according to the how much units you are sending to the grid people, means regarding that they will pay. Here how the solar system fit together. So what are the system we need? Here majorly we will discuss with the off-grid solar system. We need 4 basic components: solar PV panel, charge controller, inverter, and battery. So how the solar system fit together? How we need to fit at our home application solar PV system. So these are the 4 major components we need. Solar PV panel we need, charge controller we need, inverter we need, and the battery we need. So here components of the solar grid. If you observe here, the charge control, if you make a real-time product, if you are observing, this is the charge controller in off-grid solar PV system. These are the solar panels and these are the batteries, and this one is the inverter. Suppose if you people are estimate how much per month, if you take an assumption, you are consuming power, how much power you are consuming? 500 units, take an assumption 300 units. If you take 300 units, then how to install basic off-grid solar PV system for our home or your home. You need to install solar PV system, means that our home applications, what are the steps we need? We already discussed what are the components we need: solar channel, charge controller, inverter, battery we need in off-grid system. We don't want to depend upon grid connected system. So if you people think we need to fix solar PV system, rooftop PV system, means on top of your home, means then you need to observe step 1, you need to calculate home load. Home load means loads, what are the loads are there? AC loads, DC loads, what are the loads are there? So AC, DC loads, how much power you are consuming. So the battery selection, step 2, you need to go to the battery selection. Then step 3, solar panel selection. So depending upon the load only you need to select battery, because more than the load if you select also it will be waste, right? So depending upon the load, suppose you people are consuming 300 units per month. So according to that, if you select battery, it will be sufficient. So solar panel selection, suppose 300 units you are generating, right? So for that 300 units, if you take 18.6 open circuit voltage, 18.6 open circuit voltage, 24 maximum voltage. So 335 wattage panel if you take, means, so then 1000 watt, 1 kilowatt solar PV system if you install, means how many panels you need? 3 panels you need. So if you take 3 panels, then by taking that 3 panels, if you connect it to series manner, means then 1 kilowatt you are generating power. But what is the open circuit voltage? 18.6 open circuit voltage. So by connecting these 3 panels and you are connecting to a charge controller selection and inverter if you connected, means then it will give 4 units per day. Whatever the weather conditions, 1 kilowatt solar PV system, by connecting a solar charge controller and the inverter, if you connected, that means 1 kilowatt PV panel, it will give 4 units per day. Per month, how many units you will get? 120 units you will get. But how much power you are consuming per month? 300 units, right? So if you take 3 kilowatt solar PV system, if you take 3 kilowatt PV system, then how much power you will consume? 360 units you will get per month. So how much excess power you have? 60 units you have. If you want to connect, if you want to store that energy in grid connected in your battery means you can store that energy. Otherwise you can connect it to that energy to the grid people means that grid people that for that 60 units they will pay the bill. So daily if you averagely you will calculate, one day you will utilize 6 units, one day you will utilize 10 units also. So depending upon the load operation at your home application. So mounting the solar panel, we need to select step 1, step 2, step 4 charge controller selection, step 5 inverter selection, step 6 series and parallel connection, step 7 mounting the solar panel. So we need to fix the solar panel on top of your home side. So you need to calculate first load, how much load. Here for assumption purpose I am telling 6 units. So if you take what are the loads at your home, you need to observe. So small loads, basic loads, we have large appliances and special loads are there. So basic loads, if you observe common people also, they will have one fan, one LED lamp also available, right? LED street lamp, if you need, if you are in your statement, LED lamp, that those are the basic things. So special loads means AC. If the people are middle class or luxury people, compulsory they will fix one AC. So the humidity is more, right, in Chennai. So most of the people, middle class people, they will fix compulsory ACs only. So special loads you are adding air conditioner. Then electric heater you are fixing. So large appliances. So you need to cook the home. If you are avoiding the gas, you are avoiding the gas, then you are preferring with electrical furnaces. So then these are the special large appliances. Refrigerator, you need to, whatever the vegetables, all the things you need to keep in the refrigerator means these are the large appliances, these are consuming more power. You need to first select the loads. So after selecting the loads, you need to select battery, then you need to select how many solar panels you need to select. So overview of the off-grid solar PV system. Once if you observe all the loads at your home means, then you people need to fix solar PV panels. By connecting here, if you observe here, solar PV panels, here I connected in a series manner. By connecting the series panels, then I can increase the voltage levels, right? So here also some problem will occur. When we people connected to solar panel means, if first 1 month it will generate more amount of power, it will fine. When we purchasing a new product, then it will work fine, right? Initial stage. Later 3 months we need to observe. Why here preferring solar charge controller means, the panels will make shade out, right? The solar PV panels, whatever what you are purchasing, it will be shade out. So then how you people will track the power? Solar PV panels will shade out. Otherwise, if you are not cleaning the solar PV panels, the dust particle will cover, right? The dust particle will cover on the PV panels. So by taking this solar charge controller, you can track the maximum power at any time. Solar, that battery power you can store in the battery, solar battery, and that battery energy you are taking solar inverter. So this is the user, right? So here user, this DC we are converting to the AC, then we are converting. So diesel generator, it is optional, we are fixing. So here this is the overview of the solar window. So what are the types of solar charge controllers are available? We are talking about, so we are fixing the solar PV panels, but our main aim is solar charge controller. So it will only track the maximum power. So a solar charge controller, if you observe here, this is the solar charge controller. A solar charge controller is an electronic device which manages the power going into the battery bank from the solar array. So from the solar PV array, it will observe how much power we are transmitting, we are generating the PV panel. If daytime, at morning time, the sun temperature is very less. So the irradiation rays which are coming from the sun, it will be give less voltage only. It will fall on the solar PV panels. That PV panels, so that open circuit voltage 18.6 only, but it will generate low voltage. That means less than the 18.6 only it will generate. So at the time, this charge controller will help to track that, to achieve our requirement. It will help to, it ensures that the deep cycle batteries are not overcharged during the day and that power does not run backwards to the solar panels overnight and drains the battery. Here, this is a basic type of charge controller. How many types are there? We will see here how many types of solar charge controllers are there. Here, we need to question ourselves. So, why should we need solar charge controller? Why should we need solar charge controller? We are generating from directly from the PV panels, we are generating the DC power line. Directly we connect it to the battery, means it will store from that battery we can connect it. But come here, but specifically we are mentioning charge controller. So what are the charge controllers? Why we need means basically solar charge controller device voltage and opens the circuit, halting the charging when the battery voltage ascends to a certain level. At a certain level, it will maintain, it will either low voltage or high voltage, it will maintain. More charge controllers utilized in a mechanical relay to open or shut the circuit, halting or beginning power heading up to the electrical storage device. So this will help to store the maximum power. So mainly there are three different type of solar charge controllers there are. So simple one or two is stage controller. So it will maintain either voltage or control. Stage 1 controller, simple controllers that are open circuit voltage. It will maintain open voltage levels only. Then we need to go with the pulse width modulated controller. Apart from the simple one and pulse width modulation controller, maximum power point tracking will help to track the maximum power. Whatever the problems we did, shared out, we are saying that when we fix the off-grid system, shared out problem will occur, then voltage mismatching problem will occur, and the temperature, sunlight, atmospheric conditions are different whole day. So it will depend. So to overcome those disadvantages, maximum power point tracking will help to track the maximum power whatever the weather conditions may be. So in this maximum power point tracking, so how many types of maximum power point tracking are there means? One is basic one, fractional open circuit voltage, and perturb and observe control algorithm, then incremental conductance algorithm, fuzzy logic controller based control algorithm, then partial swarm optimization, PSO, partial swarm optimization algorithm. Now recently the solar PV companies, they are implemented with artificial neural network also to track the maximum power at whatever the condition may be. So whether it is a rainy or dirty, whatever the condition, to track the maximum power from that solar PV panels means, but to identify the maximum point means these MPPT algorithms will help. And here, what are the benefits we will get by using a solar charger? Protects the battery from overcharging. So this charge controller only will control, right, how much power we need to supply to the battery means it will only control. So reduces system maintenance and increases battery lifetime also. Reduces system maintenance and increases battery lifetime. Auto charged indication reliability is high. 10 amp to 40 amp of charging current is available. Monitors the reverse current flow also, it will monitor automatically. And here, what is MPPT? Solar charge control means an MPPT charge control is more expensive and highly efficient than a pulse width modulation charge controller, and it is often worth to pay the extra money. So maximum power point tracking controllers adjust their input to bring in the maximum power possible from your solar array, and you can also vary their output power to match the attached battery. This means that charge controllers are more efficient than the pulse width modulation controller. Here, what are the applications are there? So the application of charge controllers, if you are observing here, solar home systems, clinics, schools, rural businesses, tourism, and solar water pumping, and solar mobile charging, stations, telecom, two-way radios, street lighting, and signs, mini grids, small portable appliances. So in all these cases, we can implement the off-grid system. So in future generation, we will see in all the towers, so Airtel or Reliance Jio, they will take communication. For the communication purpose also, we need some power, right? So in that case, off-grid system they will implement. They will focus on that one. So here if you are observing some more examples by visually understanding the off-grid system, how it will work means, here you can observe here a street vendor, he is selling the fruits on a street. Here if you are observing, he need, when he will stay up to 9, right? If you observe the surrounding your street at your Chennai city or Hyderabad city or Bangalore city, in major city, the street vendors, how they need to charge there. So the top of this wheel, they are fixing 2 solar charge panels. 2 panels they are fixing, so they can utilize that power by implementing. So they need to glow, right? They are fixing one bulb at night time. During the night time, that bulb will glow, and they will. So if you observe, this is a fruit. He is a fruit vendor. So if you observe the pani puri shops or any bangle shops also, they will fixing some light, right? So the people may use this solar PV modules, means it will helpful also. So in daytime, they will charge the battery. They will generate the power. They can generate that. They can store that battery. They can store that energy in the battery. During the night time, they will utilize that power to glow that bulb also. And here, if you observe, off-grid system for industrial application. Off-grid system in industrial appliances, we can use this type of modular system. This type of off-grid system, industrial appliances. And here, in this one, this is the off-grid industrial appliances, solar modules, solar inverters, and AC loads. So in industrial area also, we can create a small industrial area. We can create off-grid system also. The batteries and generator optional. And here, these are the applications. So off-grid system applications are home lighting. So if you observe the solar, previously in olden days, which we are using LED lamps, right? So lanterns we are using. Solar lamps with community charging. It contains a LED lamp and a rechargeable batteries. These lamps are charged at charging stations to run by rural entrepreneurs. We need to give some motivation to the rural people, means they will need to adopt this type of technology also. Solar lamps with individual PV panel for charging. For charging also they will use. So rechargeable battery and individual solar panels. These solar lamps recharge during the day. We can charge this one at night time. In agriculture purpose also, if you people are going to agriculture land, your farming land at night time to give the at night time, you can take these type of lanterns also. These type of lanterns are rechargeable torch lights also. You can charge by using a single solar panel. And here, solar power now a reality at Jaipur railway station. Now the Indian government, their Rajasthan government, they are implemented in their Jaipur railway station. So a rooftop installed solar panels produced 600 units to 260 units of electricity on the maiden day on Friday 25 2016. They are installed this solar installation. Rooftop, this one is the rooftop one, so which was 35 units more than its daily capacity. That means this solar railway station will consume some power, right? More than that, by installing a rooftop solar PV system, more than whatever the power we are this railway station consuming, more than that 35 units it is producing daily. The operation was inaugurated by the General Manager of Northwestern Railways and Singhal, who said the energy harnessed from the solar panels will help Jaipur railway station save 7.2 lakh on power bills annually. So per annum they are saving 7.2 lakhs. So projection is produced 50 kilowatt power in a year. It will produce 50 kilowatt panel. So like that, if we install on our top of our college also, it will benefit. And here we will see in MATLAB Simulink model how to design a MATLAB Simulink model. Here MATLAB Simulink, it is a vast opportunity. See, so everyone know MATLAB about technical computing. So we can use block diagram editing, non-linear simulation, and continuous and discrete simulation, asynchronous and non-uniform sampling simulation also. So integration with MATLAB and external. So in all these domains, just about here we can say in communication, radar systems, automotive industry, monitoring system, so financial management, so Sensex, we are biological systems, aircraft and spacecraft dynamic and system, ship system, ship propulsions also we can design a model. So MATLAB normally have 3 steps it have. So model in the loop we need to design first. So you need to fix in your mind, you are fixing 3 kilowatt solar PV panel you need to install. Then according to that you need to generate. So here I will show MATLAB. So this one is the MATLAB. So here this is the command window. MATLAB initial stage compared to other programming language, it is purely working on mathematical modeling only. So solar PV system we are discussing. Suppose if you people need to design a solar panel model, then how you people design? How you people will design, then how you need to analyze the model. How you need to analyze the model, we need to think. Here, this is the command window in MATLAB Simulink model, and in this command window, whatever the values, whatever the vectors. So initial stage for electrical engineers and scientific students only it was introduced. Later, all the engineers they are adopted this MATLAB. So MATLAB have number of toolboxes. All over the world, more than 6,500 universities, they are working on MATLAB only. So research scholars and whoever working on electrical or mechanical or computer science also, they are working. Here we can show some basic solar MPPT charge controller model. Here I will show, and this is the workspace. Whatever the variables you are typing here in command window, if you are typing any variable name, any vector, if you type here, if you type any vector, it will store all the variables here. So whatever the vector you are typing here, that vector it will applicable here. So in the command window we have number of apps are available. We can write script also. Before this MATLAB, Fortran language, C and C++ languages are there. So we need to, the people who are engineering students, they are feeling somewhat difficult to understand the programming languages. So then the Cleve Moller, a professor of in Mexican University, he was invented this MATLAB software. So here I will show one simple basic simple model how to generate solar PV system from the solar PV system. Here I took from the library. This is the library. This is a command here, a solar MPPT charge controller. I designed a solar MPPT charge controller here. You can observe here, everyone. Here, if you see here, I took one PV array. A PV array I took here. Here in the Simulink model, we have number of toolboxes here. Here you can type here PV panel. PV panel, if you type here PV panel. PV panel, if you type here. If you type here PV panel. Here number of toolboxes are there. Here Simulink, Simscape and Simscape are all there, right? So in the Simulink, Simscape we are interfacing. We are interfacing with the Simulink and Simscape only. So if you are strong in any 5 toolboxes, so the companies, whatever the Renault or Bosch company, they are working on this one. So here Simulink and Simscape is an electrical engineering student. They will utilize Simulink, Simscape, neural network toolbox, fuzzy logic toolbox. They can work on this one. So research scholars also they can work. And here Simscape is there. In the Simscape, power system and specialized technology, renewables is there. Here I took solar. From the solar, PV array is there. photovoltaic array. So advanced versions, advanced PV panel version, advanced photovoltaic panel version 2000. Now I am using 2016A version. So now they released 2020A also. MathWorks people, they are introduced 2020A also. Here if you take a PV array, if you take a PV array to your model, first you need to observe according to your requirement. You need to select any model data, some data they are given. According to that, if you need to select data you need to select. Here I took a solar PV panel. In this panel, here I took one PV panel. This is the PV array. In this PV array, you need to observe here. Double click on this PV panel. If you double click here in this PV panel, if you double click here in this PV panel, if you take here number of companies, they are giving different data. Number of companies, they are giving data. Here you can look at here. So block parameters are there. So the module, which module you need to select, you need to observe here. So here the PV module here I selected. Here the PV module I selected here. Parallel string one solar. So here you can select any PV module. But here actually I selected a Trina Solar TSMM module. Here you can select here. From this you can select number of data sheets are different companies, they are giving according to our requirement. Suppose we are designing a 5 kilowatt inverter, 5 kilowatt PV inverter in off grid system means, then according to our requirement we need to select. Then here also parallel strings. How many parallel strings you need to connect? Suppose here 10 strings. We are discussing 3 kilowatt inverter, right? In this 3 kilowatt inverter, you need to connect 6 solar panels. Means according to that, you can give the 6 solar PV panels. And parallel strings, if you connect it to 1 means, then here the cell temperature, they are giving cell temperature degree 45 or 25. The temperature you need to give, and the wattage, how much irradiation we are getting. Sun irradiation you need to give here means, then if you observe here plot characteristics also. Solar PV characteristics, MPPT PV characteristics, if you observe the plot characteristics, you can observe here in this model, in this solar PV systems, you need to observe here solar PV characteristics. So array 1000 watt meter, specified temperature if you are observing here. How much power, what is the, you are selecting here, how many panels? 6 panels, 6 series connected modules you are selecting, 1 parallel string only. So according to this, the irradiation, power, voltage, PV characteristics, voltage and current characteristics, here you are observing. Voltage and current characteristics, PV characteristics also you can observe here. This is solar PV voltage, power, voltage and current. Array type is, here we are selected Helio Solar S19U235. So 6 series modules, 1 parallel strings I selected. So here the temperature at 25 degree temperature, how much power? 45 degree, how much voltage we are getting? 200 voltage, near to 5 to in between 8 amps we are getting. The power, how much power? So 200 into you can calculate 6 or 8. So here we are getting voltage power characteristics means here we are getting more. So according to our model we can design anyone. So this is for sample purpose only I am telling, and here you can close this one. So then I connected here I am removing this one PV array. So in this PV array, what I selected here? Here IR is there. Here IR is there. This is irradiation temperature watt per meter square. Irradiation temperature I took here 500. From the Simulink design I took constant block. That constant block name I given. Here I took constant block only. That constant block name I given irradiance. Irradiance I given, the name here I took 500. 500 I given the name here. 500 I given. Then the temperature degree, how much temperature? 25 degree temperature I given. So then in this PV panel, how much voltage I do? How much? In this PV panel, if you double click in this PV panel, if you observe here, I selected here 10 module strings. Here in this PV module, I took Trina Solar TSMM 250 AC A05.8. So the maximum power here we are getting by selecting this one, the maximum power here we are getting 249.86 wattage. So this panel is 249 wattage panel. That means approximately 250 panel, 250 voltage panel. So open circuit voltage how much? 37.6 voltage. Voltage at maximum power is 31 volt. So the temperature is 25 or 100 also. It will give how much power it will give? Open circuit voltage is 37.6, but it will give maximum condition also 31 voltage only will give. So this one I take cells per module. How many cells we connected means 60 cells, and short circuit current this one is 8.55 amps only. 8.55 amps, and here the irradiation temperature here I took 850 only. So 25 degree specified temperature I selected. So 850. You can plot graph means graph also will come. We can visually see here the plot how much plot. What is the graph here? 0.8 kilowatt per meter square, 0.5 kilowatt meter square. Here you can observe clearly 5 kilowatt of inverter, 5 kilowatt of solar PV system we are generating. The voltage, this is the voltage, and this one is the power. This is the voltage and power. Here 0.5 kilowatt per meter square or 0.8 kilometer. Here temperature we are taking different temperature. Irradiance we are giving 800 or 500. So in each one it is showing that model. And here I am closing this one. And if you observe here, so here I connected one bus selector. Here I connected one bus selector. The bus selector measurement port is there inside of the solar PV panel. How much voltage it will produce, how much voltage it will generate, how much current it will give, it will tell. It will, when I connected to the measurement port to a bus selector, VPV, IPV, diode current, irradiance. Here I connected. Now we are discussing about MPPT transition at daytime, morning time. The voltage here, if you are observing, the voltage here is here the voltage and current we took. So in this MPPT algorithm, we took here voltage and current. If you are observing this MPPT algorithm, this is a basic, simple perturb and observe algorithm. A basic, simple perturb and observe algorithm. In one case only we are observing. Here I took one memory block that is will act as a delay. So initial stage the voltage is 30 voltage we are generating. After some time whether the temperature may increase -1. That means change in voltage. Change in voltage. So the change in voltage, whether it is increase or decrease, it will tell. It will take automatically. And here the temperature automatically increase 26 or 28 temperature. So the temperature, change in voltage, change in current. Here I connected one product block I took here. Then that product here change in power I get and power. So initial power, change in power I am getting here. Then this I connected to the one addition block diagram. Change in power minus change in power. Similarly, here I took again one more addition block. Voltage, input voltage, change in voltage I took here, and delta P and delta V I took here. Then I connected to the if else based condition switch. So if else based condition switch, when I connected here, this delta P delta V greater than 0 switch, how it will turn on? We are connected to one boost converter. If in case the voltage level will be decreased at a daytime, but we need to satisfy the load side, right? We need to satisfy the load means, so here I connected one boost converter. For that one, the charge when it will activate delta P delta V greater than 0, it will take upper leg switch. So this if else based condition, this switch will activate. If delta P product delta V less than 0 means it will activate. and here I took how much saturation block here I took. Then in this repeating sequence block 4 e power minus 4 I took. So 10,000 frequency frequency hertz I took. So normally in DC-DC converter topology we can take up to 20 kilo, more than 20 kilohertz frequency also we can take. Here 4 e power minus 4 I took here. This time values here I given. Time values means frequency values only, and the output values here I given 0 to 1, and here I took 1, and here if you are observing 1 I took, 0 1 I took. So then I connected to this one, this if else condition switch, here I will generate duty cycle. So DC-DC converter topology we are getting. DC-DC converter topology, if you are observing, compulsory duty ratio is there, right? Duty ratio always in between 0 to 1 only. So that duty ratio I connected to this boost converter. This boost converter I connected. So here why I connected to the capacitor means to reduce the ripple level voltages. To reduce the ripple level voltages, I connected one capacitor. This is the boost converter. Here DC link capacitor also I connected. This DC link capacitor will help to reduce the ripple level, because we need to give the constant DC input voltage only. So that's reason here PV per a MPPT controller boost converter I do. So this one is a two-stage conversion, it will be done. So when you need to convert this DC into AC means we can connect here one single phase inverter means it will be fine. So here how now the go to from block I connected to the display. Here we will see how much power we are generating. Here I am running the model. So here why I took power GUI. Here I took power GUI, right? In this power GUI block, power GUI, power graphical user interface. So in all our mobile applications we are giving one screen lock, right? Screen lock or fingerprint we need to give, right? So that one, that purpose here we are interfacing with the Simulink toolbox, Simscape toolbox. That's the reason here I took power GUI, power graphical user interface. So when I run this model, here I am running the model. How much power we are generating from the PV panel, how much voltage we are generating, how much current we are generating, we can see here. And here the output voltage, whether it is boost up or step up voltage or step down voltage, we will see here. Here it is compiling. We will see here it is compiling. You can observe here. It is compiling. Wait a minute. Here I will show somewhat. The MPPT charge controller, we are boosting up the output voltage. Whatever the input voltage we are generating, that voltage I am boosting up here. Here we will see here how much voltage we are getting. Here it is running now. Here if you observe here, it is taking some time. Here look at here. Look at here. The PV panel power, the how much power we are generating from here means here you can observe here PV power near up to 300 voltage, near to 209 or 15.86 current we are getting generate from this PV panel. This is the PV panel voltage. So approximately the PV panel 5 kilowatt PV panel I took. 5 kilowatt. How much voltage it is producing? 309.9 voltage. Then the current how much? 16.01. Here if you are observing here, PV power I product here. So here VPV IPV I took now. So this PV panel I took 250 wattage, right? So I took a module also. This VPV IPV I product here means in this display I am showing 4981 power it is generating this PV panel. Then output power how much we are getting? 309 point approximately 310 voltage we are getting. 16.07 current this solar panel is produced. Then I connected to the MPPT controller. Then I connected to the one boost converter. How much power we are getting here? How much power we are getting here? Look at here, output voltage nearly approximately I am getting 594.3. So input voltage of solar PV panel is 3010 and output power near to 594 I am getting. So then you can observe here the pulse width modulation and the output voltage how it will be, you can observe here. So I said before the load I connected one capacitor. So in this capacitor will reduce the ripple level voltages. Here I connected one scope. How the open circuit voltage it is, see that one. Look at here. Yeah, look at here. All of you observe here. Look at here. This is the pulse width modulation controller 0 to 1 only. In DC-DC converter topology, here look at here. The MPPT, look at here. So this is the 0 to 1 is the this pulse width modulation, this one. This is the pulse width modulation. So here we are giving solar PV panel, it is giving 300 only, 310 approximately. So we are boost up the output voltage by implementing a MPPT controller, maximum power point tracking controller. We are improving the voltage. So it is reaches to some peak value and it will be settled at one point. It is reaches to some peak value and it will be settled at one point. Here, so and once again, so this is the solar how to generate power. So we are once again our sincere gratitude to the management of Jappeiar Engineering College. And our sincere thanks to madam, the HOD madam and co-convener sir also. And thanks for your patience, thanks for your attention, and I hope you people will get some knowledge by attending this webinar session. Please subscribe our channel for more updates. Please subscribe our channel. Every day we are updating 2-3 webinars on different modules, computer science people, electrical, electronics, IoT, regard all the domains we are covering some webinars. If you subscribe our channel means you will get some notifications. You can watch there and you will get more knowledge and you will be more passionate about the technology. You will be more passionate. The world is more every day, every year if you are, it is transforming, right? So, and once again, thanks to Jappeiar Engineering College, and thanks to all the participants. Give your valuable feedback and comment below, and thank you all.